Uh, is my screen visible and am I loud enough?
Yes, sir.
Okay. Uh, yeah, good. So just a minute. All right. So fine. This is revision session two, uh, and this is mostly on week 3 and 4. I think two sessions already are held, in which we had first revision session and doubt clearing session, right? So this is like you can consider this as a third session, which is revision session two, right? So we'll be primarily discussing here on week 3 and week 4, and this is very similar to what we did before, and I did not change much on this. But what I have done is I have additionally added some question compared to what we had done it before, because this week 3 and 4 is the problems. It primarily involves the graphings, and what I believe is like if we are good enough with these kind of things, then I believe that you can solve those questions like whichever comes in your exam. And I have gone through the paper, the qualifier paper, and I have seen that whatever we'll do today, that will suffice the need for your week 3 and week 4, at least from the graphing part, and at least the rest all is your practice and all that thing, like how you visualize the question, right? So that is all. But certainly, like whatever we are going to do, it's going to be very important in terms of your reattempt qualifier. So this is all like we're going to do, but I have some questions to discuss. So it's going to be like I have taken some sample questions, and we can discuss more on those sample questions. So this is how it's going to be. So before that, do you have any questions for me before we start?
So just one question. Will we have a recording of the session shared with us, or how does that work?
I think it will be live on YouTube, I guess. I think so. Because the previously, like day before yesterday, whatever we did, it was live. Uh, and I think it's going to be the same here. Let me just check once.
Yes, sir. Because I won't have time to complete the entire session, so I'm just curious about that.
Okay, okay. I guess it should be recorded. I can't really think of it. But yeah, I think it should be. Let me just check it, like if it is available. Is it going live on YouTube? If it is, yes, then I think it will be recorded.
No, sir, it is not going.
It is not going, then
No.
so most likely it's not going to be recorded, I guess. Uh, so it's okay, no need to worry and all this. So whatever, if you cannot attend this session, so you can still watch my the previous revision session which I have taken, which was same again on week 3 and week 4. All that changes I have done is this thing that is you have to notice. That's it. The rest everything is same. So that's the only change I have made, and additionally I have taken some questions which is important. So those who are not able to join, like after some time, who might leave, maybe you can ask your colleagues, your friends, and you can at least try those questions, and at least that you can do, right? So that will suffice the need for this. All right. So we can start with that way. So what are we? So any other questions do you have before we start?
No, sir. Apart from this, nothing else. Thank you.
Any other? No, no questions. Can we start? Okay. What are you guys expecting from this session? At least that if I have an idea, I can orient myself. Anything? And one thing is like you need to talk, then only it will be like good. If you guys don't talk, then it's you have to interact with me. So tell me, like, is there anything that you are expecting from me apart from this week
Uh,
3, 4 revision? Yes.
Can you just teach me that completing square method if it is important?
Completing the square method.
Yeah, I couldn't understand it.
Okay, so completing the square method is basically when you're finding the roots of a quadratic, that one, right?
Yep.
Okay, fine, we can see at the end. Okay, or you can just see the lecture videos. That is, you can actually learn it from there as well. But anyhow, let's see if we have time, we can discuss this. So let's stick on to what we are going to discuss today. Uh, so, uh, see, mostly we are going to touch upon this week 3 and week 4. And what you see here is what is really important is this graphing part. It's very important. And for week 4 as well, the graphing part is very important. Okay. So you must be thorough with these two things, at least in these 2 weeks, this graphing concept. Then in week 3, what more is important is this slopes and the word problems. Certain word problems are very important. So you should know how to frame an equation. That is something you should give emphasis to on week 3. Then reflection of quadratic function, I would say, not really that much important, but yes, you can still think that, yeah, this plays role. So this is also important. And coming to week 4, again, this graphing is important and related word problems. So it's basically you might be given some kind, if you would have seen some standard problems wherein you have to draw the graph and then we might ask you, okay, which is above this, which is above below this, right? Where is the profit, where is the loss, and all that kind of questions, right? So those kind of like small word problems that you can expect. So this is important again. Coming to this, the other thing is this SSC. Why I have written in week 4 is just a hint to tell you that, okay, SSC is something you learnt in week 2, but SSC has been applied in week 4, so you can give emphasis to this. Like do some problems which involves like polynomial, right? And with the concept of SSC, right? So this is very important again. Then what are the type of function like 1, 1, onto bijective? Like these are like small things which involves in week 4 specifically. That's why it's mentioned here. Okay, so these are the broad topics that we are going to look over. So as I told you, like whatever the thing we had written before, like I think most of you would have attended my previous revision session in the sense of like previous qualifier thing, right? So I have not changed that thing. I kept it as it is. I kept it so just because you can correlate with that. I could have done it differently altogether, but I did not make any changes. It's just that, you know, it will be a flashback to you guys, like whenever you are reading it, or like if you have already gone through this. So it's more like a revision, and there is nothing more on this. This is all you can do with this week 3 and week 4. Okay. So if if that is the case, then let's revise it. Like what is the, you know, the thing over here. So you see this, uh, you see whenever we, so I'll just start from here. Maybe I'll use different colors so that, you know, the things will be highlighted here. Right. So you see this quadratic function, it's generally represented like this, right? So f of x is equals to ax square plus bx plus c, and what we have to note here is this a is not equals to 0, right? Because the moment this a becomes 0, this will become linear, right? This will be just this, right? So it will not be a quadratic function anymore, but it will become a linear function, right? One more thing that you have to notice is what is this terminologies, okay? So the terminology that you have to understand is like whenever we say this leading coefficient, so leading coefficient is nothing but the coefficient corresponding to the x square for a quadratic function, okay? Or let's say if you have a polynomial, if I say p of x is equals to ax to the power of 5 bx to the power of 4, and if I tell you what is the leading coefficient here, so leading coefficients, the coefficient which corresponds to the highest degree of that polynomial, right? So that is called as a leading coefficient, okay? So could you tell me what is the leading coefficient for this polynomial p of x?
B.
B. Okay, so
B.
you understand this now, right? Yes. So this is what we have to understand from here. When we say leading coefficient, it's just that, you know, whichever the coefficient for a highest degree term, right? So that is something we have to understand, right? So this is called as leading coefficient. And okay, so a quadratic function, what is the graph for this? So you see, whenever we study any function, what we should know is like what, okay, what is that function first of all, okay, and what are certain constraint or conditions for that particular function. That is another thing that we have to know. And thirdly, what is the graph? How does that visually that function look like? Okay, so this is something we have to understand whenever we learn about a new function. For an example, now we are learning about quadratic function. So we must know, okay, what is that quadratic function at first place, and what are certain conditions? Like we have seen, this is what this represents a quadratic function, wherein this is the condition which is given, right? This, if this is the case, then yes, it is a quadratic function. The next question is, how does this graphically look like? So you see a quadratic function is, when you draw the graph for this, you see it's in the shape of parabola. It can be either opening upward or downward. And what we have to know is, since this is quadratic, this is to the power 2, you would see these endings are on the same side, right? Unlike cube, where you will see that, something going like this, right? So this is what we notice, isn't it? So when you have odd degree, it goes in and the endings are on the opposite end, and when it is an even degree, the endings are on the same side. Well, this is something we can elaborately discuss when we are discussing week 4. But for time being, what you have to understand is that this represents a quadratic function. This is leading coefficient. For a quadratic function, the leading coefficient cannot be 0, and the graph of the leading coefficient, the graph of the quadratic function is a parabola, which can be upward or downward or whichever side. That depends on the various coefficients which are present for the various terms here. Okay, so now let's understand what are the role of this A, B, C, given that all the conditions are being fulfilled. Okay, so now you see this, when A is greater than 0, what happens? So you would notice that when you try to draw the graph, when A is greater than 0, you see that parabola opens upward. It's going to be something like this. Okay, so this is something we have to know, right? So if A is greater than 0, parabola opens upward. That is something we have to take it from here, and something that is you can verify even by drawing the graph. You take any random equation, okay, make sure that A is greater than 0, draw the parabola, you would see it is opening upward. Okay, likewise, if A is lesser than 0, the parabola opens downward, right? It's something like this. Okay, so this is another thing that we have to know. What happens when A is equals to 0? It's simply a straight line, right? Okay, so we are done with the A part. Like, this is what we can do, right? So we can just exploit everything, like if A is greater than 0, A is lesser than 0, when A is equal to 0, what all thing can happen, right? Then what is the next coefficient that we should discuss? Let's say we are going to C. Now what does this C represent? C is nothing but the y-intercepts. Now what do you really mean by y-intercept? Y-intercept means wherever this curve cuts the y-axis. For an example, if I have to draw this parabola, you can see this parabola which is drawn here. You see this, the y-intercept is this, wherever it cuts the x-axis. So it's like, sorry, y-axis. So if this curve cuts the y-axis at this place, so whatever this distance is from this to this is your C. Okay, so in this case, what could be the possible value of your C? Can C be 10? Can C be minus 10? Can C be minus 5? Can C be 0? Can you tell me which among them are right for this parabola?
Minus
Minus
10,
5.
minus 5.
Minus 5, and can it be anything else?
Minus 10.
Yes, it can be minus 10 as well. It's just because it's below the, if you see this is on the negative side of the y-axis. It cuts the, this parabola cuts this y-axis on the negative axis, right? So that's why it can be minus 10, it can be minus 5, right? We are not sure what is that exact value, but we are very sure that it cannot be 10, right? Because 10 means it has to cut somewhere here, and it cannot be 0 because it's not passing through origin, right? So we are sure of this, right? So this is something you have to understand from here. All right, so now we understood, okay, C is basically my y-intercept. Okay, now what is the role of B? So because we have looked into this A, we have looked into this C, now what is the role of this B? That is something we are going to look over. So B in itself has got not much role, but B in combination with A has got some interesting role to see. Okay, so if B is along with A, then you see what happens. So there is one concept called axis of symmetry. Okay, so you see this axis of symmetry is given as minus B by 2A, right? So this minus B by 2A, it tells us whether the parabola is on the left hand side of the y-axis or on the right hand side of the y-axis. But what do you really mean by saying that it is on the left hand side or the right hand side? So you see this, a parabola, you can actually divide this parabola into two halves by a line called axis of symmetry. So you can see this line. If this is your parabola, if you can actually divide this parabola into two different halves, right? Equal halves. And that line which divides this parabola into two halves is called as an axis of symmetry, which is given like this, which is given by this formula. That is nothing but x is equals to minus b by 2a, right? And this minus b by 2a, now when I'm telling you whether the parabola is on the left hand side or on the right hand side of the y-axis is something determined by this, that is minus b by 2a, right? So that itself, like if the axis of symmetry is on the left hand side, then you can say that the parabola is more shifted towards the left hand side of the y-axis. So that's why we say that, okay, whether the parabola is on the left hand side or on the right hand side. So this is the concept. Okay, so then how do you understand this? So this is something given as minus b by 2a. This is something called axis of symmetry. Okay, so minus b by 2a is axis of symmetry. That is something we have to know, and it's very important concept because this is something it will be used every time you see. So if I have to give you one example, so if I have to tell you, okay, so if your equation is 5x square plus 2x, let's say not 2x but 20x, that's it. What is the axis of symmetry for this?
Minus
2,
4.
sir.
Minus 20 upon
Minus
5.
2.
Minus 4.
Minus 2.
Minus 2.
So how do you do this? Because this is my a and this is my b, right? Because you see this a correspond, the coefficients of x square is a and coefficient of x is b, right? So you see this, that is how we are able to, identify, okay, what is my a and what is my b. And when I substitute this here, so what do I get? Minus 20. Why minus? Because the formula says you have to take minus b by 2a. So minus 20 by 2 times of a, and a is nothing but 5, so which makes it minus 2. So axis of symmetry, so whatever the value you get, this is x is equals to minus 2. How do you draw a line x equals to minus 2? Is this a horizontal line or a vertical line?
Vertical.
It's a vertical line, right? So it's something like this. So it's a vertical line, right, parallel to y-axis, right? So that is something we can see from here, right? So all right, so now having known this, like, okay, what is the axis of symmetry, let's go on to the next concept, that is called as slope. Fine. So you see this slope, you would learn this more when you are going to the week 7 onwards, like when you are dealing with the calculus. How did we get this formula even? Okay, so for time being you can just think, okay, slope is something given by this formula, that is 2ax plus b, right? So is a slope constant for a quadratic equation? Can anybody tell me this?
No.
No, it is varying, and it is varying by this x, right? So for different value of x, you get a different slope. Unlike straight line, just imagine you had a straight line, and what we used to say, y is equals to mx plus c. You see this, m was fixed here, or for an example, if I have to give you, y is equals to 2x plus 5, and we used to say that this is a slope, right? Where slope is fixed here, right? Slope is fixed here, but over here this entire thing itself is a slope, right? And it is varying by what? It is varying by x. So as the x value changes, the slope value changes, right? So that is something we have to understand from here. So you see this, the slope is variable here, right? So a quadratic equation will have a, infinitely many slopes, right? So that is something we have to understand. Okay, so for an example, if I have to tell you, come to this part in a while, what is the slope of this function? I'll change this equation. 2x square plus 5x plus 10. What is the slope for this function f of x at x equals to 1, say? Come on, fast.
9.
Yeah, 9. Right, so how did you get that? So first of all, if this is the equation which is given to us, f of x, then you write it this slope formula. So what is the slope formula? 2ax plus b. Okay, so what is a from here? 2 into a is 2x, and what is b? B is 5, right? So what do you get? 4x plus 5. And now what are we telling? What is the slope of f of x at x equals to 1, right? So what all you have to do is just substitute x here. So x is 1, so 4 times 1 is 4 plus 5, which makes it 9, right? So this is what we have to understand. So this is what the slope formula. Okay, so I'll quickly go through all these and we can discuss more when we are discussing more problems on this, okay? Because that is the most important thing. This is something I I have to assume that you guys know this, and it is just that, I'm brushing up so that, the last moment you can understand, so that you can recollect everything, and we can all of us be on the same page while solving the questions, right? Okay, so now what do you mean? The next concept is vertex. So we are done with understanding quadratic function. right? And we are done with understanding the coefficients of each terms of the quadratic equation, right? Then we learned something called slope, and now we are going with the next concept, something called vertex, right? So what do you mean by vertex? So vertex is just basically a point. And where do you see this point? You see this point at the tip of the parabola, something here. Okay, so we know that this is called as axis of symmetry. So if this is my vertex, so my x coordinate for this vertex is my axis of symmetry, right?
Yes, sir.
And how do I get the other y coordinate for this? All I have to do is just substitute this x value to my main quadratic equation in order to get the vertex for this, right? So considering this as the thing, that is 2x square plus 4x, let's make it as 10. Okay, so 2x square plus 4x plus 10. What is the vertex of this quadratic function f of x? Quickly tell me what is the vertex.
-1.
Vertex is a point. Remember that.
Okay, sir. Okay.
Quickly, what is a vertex? You need
So
to be fast.
-1, -8.
-1, 8.
1,3.
-1, 8, -1, 3. Let's see what is the answer. Okay, so rest all of you can put your answers in the chat window. Okay, so now let's see. First of all, this represents vertex, right? We just saw that this axis of symmetry is the x coordinate for the vertex, that is minus b by 2a. And when you substitute this x value to your quadratic function f of x, you get the y coordinate of this vertex, right? So first of all, let us find out what is this x coordinate for this vertex, right? So minus b by 2a will give us what? So x coordinate is nothing but minus b by 2a. So minus b by 2a is nothing but minus 4 by 2 into 2, which is nothing but -1. So this is my x value, right? So basically this is -1. And what about my y coordinate? How do I get? So f of -1. So all I have to do is just substitute into this. So 2 into -1, the whole square is nothing but 2 again. -4 plus 10, right? This is what you get. And what do you get eventually from here? When you substitute this, you get
8.
8, right? So what is the other coordinate, the y coordinate you get? -1 by 8. So this point corresponds to -1 by 8. Okay, okay. One more quick question to all of you over here is, look at this parabola. This parabola opens upward or downward?
Upward.
Upward. Okay, so how can you say this parabola opens upward? What value of this expression signifies that this parabola is upward?
A is greater than
A
0.
is positive.
A is positive. Okay, so this is just to quickly cross check whether you're understanding me or not. So this is simply I ask you here. All right, so you see this, because A is greater than 0, we see this parabola opens upward. Okay, so another quick question to you is, if parabola opens upward, then will this parabola ever have a maximum value?
No, sir.
No.
It is going to be an infinite, right? Because
Yeah.
if a person claim, okay, the highest value is, let's say, 1 crore, there will be another person who will always say, no, the value is 5 crore, right? So it is not defined, in fact, right? We cannot actually find out, okay, what is the highest value of this quadratic function that it can attain. But if a parabola opens upward, what is the decent thing to ask is, what is the least value what is the least value for this parabola? It's -8, right? Because if you go up, because this is the least value a parabola which is opening upward can attain, right? So this is the most decent thing that we can ask, but we cannot ask you, okay, what is the maximum value this parabola is attaining, right? Likewise, if a parabola opens downward, then the decent thing to ask is, okay, what is the maximum value for this parabola, right? Or for this quadratic equation, or for this
Yeah.
quadratic functions, right? So this is
Well,
the normal
the
thing that
point
we have
for
to
this-
understand.
The point for this graph is -1, 8. Then the minimum point will be -8.
Minimum point is point. When you're saying point, then you have to say -1, -1, 8. The minimum value when you say it is 8.
It is
And
8. Okay.
yeah, so it's like that. Okay, so having known this, so see, whenever we are doing these kind of things, try to visualize the graph. Once you can visualize, then the rest thing is English. What is the minimum value? What is the maximum value? Whether this is opening upward or a downward, that is something we have to visualize, right? Once you have visualized it, the rest thing is English, right? You just have to understand what is the examiner really asking us here, right? So that is something we have to understand. Okay,
Yeah.
so as we
Sorry
are
to interrupt, Vicky. I think, is it that we got it in the wrong quadrant, that -1/8 should be on top, or am I?
Yeah, it should come above
Correct,
the
correct.
x-axis, I
I
Right,
think
think.
that would help us visualize better. Yeah.
right. Okay, so this has to be something like this, right? Is this fine?
Yeah.
Yes,
Thank you.
sir.
Yeah. Okay, thanks for correcting me here. So you see this? This is what the vertex look like, and now we understood that. Okay, now since we have drawn this, what is the x-intercept for this function f of x? Is there any x-intercept? So x-intercept is
No.
where this curve cuts the x-axis. The places where it cuts the. Can this curve ever cuts the x-axis?
No.
No, sir. No.
No, sir.
No. So you see, you can actually draw the graph if you can actually identify the vertex, right? And if you know, okay, what is the value of A, that itself will suffice. And if you can visualize the graph, that itself will suffice to tell you, okay, whether it has got x-intercepts or not. In other words, whether this quadratic function has got any real root at first place. So the answer will be no, right? Because this, if it cuts the x-axis, those are the real roots, right? And if it does not cuts the x-axis, it has got no real roots. I hope all of you understand this, right?
Yes, sir.
Okay, so now we understood, okay, what is the vertex. Now let's quickly get into the other part, and that is called as quadratic function in a vertex form. Okay, so how do you write a quadratic function in a vertex form? Now we know that this is our vertex, right? This is our vertex. Now, given just vertex to you, can you frame a quadratic equation? Let's say if your vertex is h comma k, right? Then how do you get your quadratic function? So, well, it's a formula which is directly given to us. So it's something like this. So y minus k, this you can see this k is something your y coordinate for this vertex. So it's written along with y here. So y minus k is equals to a times of x minus h the whole square. So you notice this a is nothing but this leading coefficient. You understand now? So again, why is it leading coefficient? Because this x is independent. It has got just one, and when when you expand this and when you multiply, you would see that x square gets this term, and that's why this a is the leading coefficient. Okay, so well, you see this. If vertex is given and if you are asked to find out, okay, write down the quadratic function in vertex form, well, this is the case. This is what you have to write. Okay, so if I have to tell you, okay, fine. Uh, okay, so given a vertex, right? A question to you is, given a vertex minus 1 comma 8, what is a quadratic function? Okay, so can you tell me, okay, what is a quadratic function? Of course, in examination it would have given 4 options for you, but here I just want you to just simply expand and tell me, okay, what is a quadratic function? Can all of you quickly do this?
Sir,
Okay, no
x square,
response.
x square plus 2x plus 9. I guess.
X square plus 2x plus 9.
Yes.
X square plus 2x plus 9, well, that is okay. One more thing I forgot to tell you is, what is the leading coefficient here, right? Because you see,
1,
I
sir.
have given h k. Let's say our leading coefficient over here is, and a is equals to 2.
Mm-hmm.
Okay,
Okay.
now tell me.
Sir, is it ax square plus a plus 8?
Now substitute a equals to 2 and tell me the answer.
So 2x square plus 4x plus 10.
That is the right answer. Because you see this here itself, you can understand. This is the vertex which I had given you, right? And I'm telling you that leading coefficient is 2. Well, that itself is a hint that, okay, this is what I'm talking about, right? So you see this? Now let's simply expand and see so that we can understand and we can appreciate this better. So now what is this k value for us? This is h and this is k, right? So what is k? K is 8, and this is going to be what? Y minus 8, and then what more do I have? What is the formula? As I'm claiming that a is 2, so let's keep this as 2, and x minus h. What is the h value? H is minus 1, so just keep it as minus 1 the whole square, and when you expand this, what do you get? X plus 1 the whole square. So when you expand this further, what do you get? 2x square plus 2x plus 2, 1. No, not 2, it's 1. And when you expand this further, what do you get? 2x square plus 4x plus 1. Right? Did I do mistake anywhere? Okay. Yeah, this is not 1, but this is 2. Right. Yeah. So this is going to be y minus 8, right? So y is equals to 2x square plus 4x, and if this goes to the other side, what do you get? 2 plus 8 is nothing but 10. So you see, you get the same equation, right? Same equation as this. So what did we notice here? When the equation was given, we were able to find out the vertex, and we found out this vertex was something like this. And then we were doing something called quadratic function when a vertex in a vertex form. Okay, when a vertex is given to us, how do we get when a vertex and a leading coefficient is given to us, how do you actually get the equation, right? So this is how we get it, right? So you understood now?
Yes, sir.
So yeah, so that is something you should know already, but we are just revising everything, so it's okay. Now let's get into this next concept. This is x-intercepts. So in x-intercepts, what do you get? Something called roots. X-intercepts is also called as the roots of the quadratic equation. X-intercept is called as the roots, right? So there are various names for this x-intercepts. It's called as the roots. It's called as the zeros of the polynomial functions, right? And how do you get these zeros? So there are so many methods. One is like factorization method, another is formula method, another is completing square method. Somebody asked me, okay, can you explain me this? We'll see if we have time at the end, we can do this. But I would encourage you to learn by yourself. It might be in the lecture, right? Or if you just know these two methods, that is more than enough to get the answer. So we'll see that. So you see this, given this quadratic function, now look at this graph. Okay, what are the roots? What are the x-intercepts for this? If this is my quadratic function, what are the x-intercepts for this?
2 comma minus 1.
2 comma minus 1. Okay, what are the zeros of this function f of x?
2 comma minus 1.
1 minus
Ah, okay, and what are the roots of this quadratic function?
2 comma minus 1.
1 minus 1.
So it's everything is same, right? So this is what you have to understand from there. Okay, so now this is all that you have to know in x-intercept. Now let's get into the next concept, that is discriminant of a quadratic function. So now what do you really mean by this? So discriminant is given by this formula, which is nothing but b square minus 4ac, right? So but again, these coefficients remain the same. Our standard quadratic function is written as this way, right? Ax square plus bx plus c, where this a is this a, right? And where this b is this b. Okay, so I'm just stressing on this fact because some of us always misunderstand, okay, what is the a and what is the b value when if I write a equation something like this. Let's say 5 plus 2x plus 10, maybe x square. What is a in this?
1.
1.
Right? So you see this, there are so many of us who actually do mistakes. So whenever you write a quadratic function, rearrange it if you want it in a decreasing order of power. Okay, and then you can identify, okay, what is ABC, right? Okay, so what does this discriminant tells us is how many roots it has got. Okay, over here I drew a quadratic function and I could see that, okay, there were 2 roots over here. But how do we determine like how many roots it has got? So that is something you can determine by this d value. If d is greater than 0, then you will have 2 real and distinct roots. Okay, so if d is greater than 0, that means if you substitute in this value, so if you are given a quadratic function and you just simply find out d, and if you see that d is greater than 0, then you can say that definitely it is going to cut at 2 places, at 2 different places, right? So this basically, this curve is going to cut, or this graph of that parabola, I mean the parabola is going to cut the x-axis at 2 different places for sure. Okay, and what if d is lesser than 0? What does this mean? It will never touch the x-axis. It will be something like this or like this, if this is the case. So basically you have no real roots. And what happens when d is equals to 0? Well, you will have 2 real and equal roots. Well, why do you say 2 real? It's because the multiplicity of that root is 2. That is why you call it as 2 real. But equal roots means it's essentially what? It's touching the x-axis at just one place and it's bouncing back. So if let's say this is 2, or let's say if the root is 10, that means how many roots it has got? It has got 2 roots, agree, but those roots are equal. Okay, and that is what it represents. So
That
basically,
means it is a repeated roots. Yes, sir.
it is a repeated roots. Correct. Okay, so this d will tell us how many times it cuts the x-axis, whether 0 time or 1 time or 2 times, right? That is something this d can tell us, right? So this d becomes important over there. All right, so now having known so much, right? Having known so much, I want all of you to answer this, right? So looking at this graph, look at this graph, okay? Is a positive here?
Yes.
Is it true? All of you, is this true?
Yes.
Yes, it's because this parabola opens upward. Is C 0?
Yes.
Yes. Why? Because look at the y-intercept. Y-intercept is 0. That is why C is 0. Okay. Axis of symmetry is negative. Is this right?
Then why is
Yes.
C0
Okay. What is C?
P where
Is
the graph
Y
touches
intercept.
Y?
ha. So
So,
over here, what is the value of C?
yeah,
0.
0.
0. That is why it is 0. Okay. Now look at this. X equals to minus b by 2a is nothing but axis of symmetry. And is it negative? That's the question.
Yes,
Yes.
sir.
Is it negative? Yes, because look at the x value. X value is negative, the axis of symmetry, right? So it is negative. So, well, this is right. Well, B is positive. Is B positive?
Yes.
No, sir.
How do you
No.
say this?
The B has to be positive.
B has to be positive. The reason is A is positive, right? If A, now look at this. Axis of symmetry, how do you get? Minus B by 2A, right? And what is your A? A is positive, right?
Oh,
So since A is positive, this entire thing is positive, and this x has to be negative. Why? Because the axis of symmetry is negative. Looking at the graph, we can say it is negative. When can this be negative? Only when B is positive. If B becomes negative, this entire thing will become positive, right? Therefore, B must be positive,
sorry.
right? And therefore, this is right. What about vertex? Can vertex be represented in this form?
Yes.
Okay, where I can also say that where P is nothing but minus B by 2A, or let's say B by 2A, because here minus B is given, so when you substitute this here, it becomes minus B by 2A, right? Okay, so now we understood this. Well, this vertex can be represented this way, where this value is something like this. Is D greater than 0?
Yes.
Yes.
Is D greater than 0, all of you?
Yes.
Look at the graph. How many x-intercepts do we have? Two
2.
x-intercepts.
2.
Therefore, when do you get two real distinct roots? When D is greater than 0, and therefore this is also right. Now look at this part. Now consider this function f of x. Okay. Now tell me, axis of symmetry is on the left hand side of the y-axis. Is this right statement?
Yes, sir.
Yes.
Yes. Why? Because this is positive,
It
this
is
is
minus.
positive, and our formula is minus b by 2a. If this is positive, then overall this makes it negative. Right? Clear? So the axis of symmetry is on the left hand side of the y-axis. So this is right. Y-intercept is 9. Is this right?
Yes, sir.
Minus B by
Yes.
2A, we will get a negative x-intercept that makes the axis of symmetry at left side. If
Correct.
minus B by 2A is negative.
Yeah.
And if it is positive, then it will be on the right side.
Right side. Okay. What is y-intercept? Y-intercept is 9. Is this right?
Yes, sir.
Yes.
Vertex is minus 1 by 5. Is this right?
Yes.
Can we quickly look at this? Minus b by 2a is nothing but what? Minus 4 by 2 times 4, which is nothing but minus 1. So I got my x coordinate as minus 1. Now I just have to substitute it here. So I get it what? 4 minus 8 plus 9, which makes it 5. This vertex is right. Right?
So
Is
y
d lesser than 0?
so y-intercept is that constant term 9.
Correct. Okay. Now, what about when do you say d is lesser than 0? How do you get this? What is the formula for d? All you have to do is substitute it here. Is this right statement? That's my question. What is my b? b is nothing but 8
S.
square
It's
4 times 4 times 9. So this makes it what? 9 4s are 4 4s are 8. 4 4s are 16. 16 times 9 is a very big number, and
144.
which makes it negative, right? So d is lesser than 0. Well, this is right? That means what? It has got no x-intercepts. So there are two x-intercept. Is this right statement?
no.
No, sir.
Right? So this is one. So this is what we had to know over here. Now let's see if we have more to discuss on this. So I think we discussed all these, so we don't have to worry about this. So I think we are done with discussing those questions over there, right? So
That
we are
example.
done with the quadratic functions as if now. All that you have to know is that's it. There is nothing more and all. Okay, so all that you have to do is just take some equations and start drawing the graph for it. Okay, and try to understand this. So I think we have done. See, we can draw the graph and we can analyze things. With the equations, we can again do all that things which we can do. Because for an example, if you can see this here, if I'll show you here, that what did we do? We started with, I'll just quickly revise you everything that what we have done. First, we understood, okay, what is this quadratic function, right? And after knowing this quadratic function, we exploited this ABC in all possible ways, right? And then we studied, okay, what is the slope? Then we studied what is this vertex, right? How we can write this vertex. Then we studied, okay, how can we represent a quadratic function in a vertex form, right? And given in a vertex form, how we can represent, if a vertex form is given, how we can identify if what is a vertex can also be done. Then what are these x-intercepts? Then what are the various names for this x-intercept? Then we also studied, when we are talking about the x-intercept, discriminant becomes very important. And then we studied this three condition: when d is greater than 0, d is lesser than 0, and d is equals to 0, right? When d was greater than 0, we saw that, okay, it cuts the x-axis twice at different places. When d is lesser than 0, it does not cuts the x-axis at all, right? And when d is equals to 0, it cuts the x-axis at one place only, right? So that is something we have to understand. And then we discussed these two problems where one graph was given, and then we identified this a, b, c, x value and discriminant value, vertex, and everything. We have figured it out, right? And when a equation was given, again we were able to do all that things. So what more you can do from this? It's just a simple equation. You have bifurcated, or you have studied, or you have dissected it in all possible way, and we have studied. Okay, all we have to do is just do some practice. Okay, and then try to visualize this kind of equations, and like that is really important, right? A quick question to all of you is, x square, just given a x square or 5x square, what is the axis of symmetry? Quickly.
0.
Yes.
Zero.
Why? Because there is no b term. B is 0, right? You can actually write this as 0x plus 0, right? Because b was 0, it's done. So you see this, you have to be this quick, right? So this quickness is needed from you, because you see we have studied it in all possible way, these equations, right? So now all that is left to you is just practice, and that is something I cannot always give you. That's left to you, right? Because I have done my part here. The rest part is yours. Now you have to practice. Okay. So having known that you know something and you are with me and those concepts are easy, and I think like all of us can understand that, let's quickly discuss one question. And this question was asked in the end term exam. This was asked in end term exam, and that is something I have taken here. So let's see how well are we prepared for end term rather than qualifier before. Okay, so let's see how well you can answer this question. Okay, so you see this, consider two quadratic functions, that is p of x, which is marked here in the green. This is our p of x, and this is q of x, whose roots are shown in the figure 2. Well, this is figure 2. Well, that name is missing here, but consider this as figure 2. Okay, the leading coefficient of p of x and q of x is 1. Okay, so that is we have to understand. That means p of x a value is nothing but what? 1, and q of x a value is 1, right? That is something we have to understand, right? So this a value is given to us here, and the y coordinate of the vertex of P of x is equal to the y coordinate of the vertex of what was this? P of x is equals to Q of x. So that also we have to understand. Now we know this vertex is represented by a point, and whatever this y coordinate value is, it is same for this and this. That means essentially this y coordinate, this value is same for them, right? Okay, now the question is find the value of D. How do you do this? Find the value of D.
Will we just add the 17 and 1 divided by 2? That's 9.
Well, okay, you're thinking of symmetry and you're telling that answer. Well, if it is symmetric, then yes, the answer would be right. But if the graph is not symmetric, then how do you approach this kind of question?
So can we say that D is minus B by 2A, and we know for P of x minus B by 2A is already 1. So that would give us D.
Okay, so but that will give us D, but you don't know what is your f of x, or you don't know what is your P of x and Q of x. Then where do you put that?
Yeah. Need to figure it out.
So first we have to identify what is our equation, right? What
X
is our
minus
P
D
of
is
x?
common root for both x minus 1 into x minus D equal to x minus D into x minus 17.
So you see this, one thing that I have to make sure is, if I want to find out the y coordinate of this vertex, I must first know what is my function, right? I must first know, because let's say if I can able to find out, okay, what is the x coordinate of this, but again I still need y coordinate, I still need a function to find out the y coordinate of my vertex, right? And they're saying the y coordinate is same. So how do you approach this? Now look at this part, this and this. Well, these are the two roots which are given, right? These are the two roots. If I have to expand this further, it goes like this, right? Now you just imagine, how did we study this? How do you write an equation, like a quadratic equation? You can write this in factors form. So this is going to be x minus 2 and x minus d and some leading coefficient as a. So this is my P of x.
Yes, sir.
Right? Can we do this?
Yes, sir.
All of you agree with this? Can we write like this? And they are
Yes.
saying this leading coefficient is 1. So I just have to forget about this. Right? Likewise, what is my Q of x? X minus d
X minus 17.
times x minus 17, right, into a. Now if I know this, I can write it in this way. I can do this, right?
Yes, sir.
Yes, sir.
Right? So to those all who are still thinking, how can I even write this quadratic function in this form? This is something I did not tell you here when I was revising you, right? But this is understood. And if it is not understood, this will be well appreciated when I am discussing week 4. Okay, so do not worry. But given a two roots, you can actually write your quadratic function. Let's say, if this is my quadratic function and this one root is a and this is another root is b, and if I want to find out, okay, what is a quadratic equation, then the simplest way of writing is you write it in a factor form, x minus a times x minus b. But again, you might have some leading coefficient, some stretch factor, right? This quadratic function can be like this as well, right? Then what is that which determines? That is something your stretch factor is determining. Let's say this stretch factor is nothing but p, and all you have to do is just simply expand, you will get your quadratic equation, right? So this is what we are telling you. Now now they have also told us, what is the other thing they have given us? That okay, fine, that the roots for them are same, right? The d value is same for both of them, right? So then what is the next approach? Can anybody tell me what should we do?
We will put these two equations equal to each other.
And what do you get?
X minus 7 is equal to
You get actually nothing, because you will cancel this x minus d, and you will be left with x minus 17 is equals to x minus 1.
yeah.
And then you will cancel down xx, and you will be left with minus 1 is equals to minus 17, which is taking us nowhere, right? So what we can do here? They are given us one hint saying that the y coordinates for this vertex are same, right? So first let us expand this and find out, okay, what is the axis of symmetry for this and axis of symmetry for this, okay? And then we can substitute and get the answer, right? So now if I expand this, what do I get? X square, tell me, minus 1
minus
plus
xd.
dx plus d, right? So you expand this, you will actually get this. I just simply use the formula, which is something I know already, but you can expand and get the answer, okay? And over here, when I expand, what do I get? X minus, go ahead, d plus 17 plus 17t, right? And this x is missing. How am I using this formula? Is you have this, this standard formula, that is x minus a times x minus b is equal to x square minus a plus bx plus ab. This is the formula. So this
Yes.
formula I know, that is why I'm able to apply this formula. There is no hard and fast rule that you should know this formula. You can simply expand and get the answer. You will still get this answer. It will be like 3 step. I'm getting it in 1 step. When you're expanding it, you get answer in 3 steps. But since I know the formula, I reduce 2 steps here. Okay. So well, that's fine. So now, why am I even doing all this? First, because look at this. They are saying the y coordinate of the vertex is same. So I just want to come to that step, right? So in order to find the y coordinate, I must know, okay, what is my axis of symmetry? So what is the axis of symmetry for P of x? Axis of symmetry. Please go ahead, tell
B
me.
by 2.
Minus d by 2a, right?
Yes, sir.
So
1
1
plus
plus
d
d by,
2
correct.
2a.
And from here, what do I get?
d
Axis
plus
of symmetry,
17 by 2.
Plus 17 by 2.
d plus 17 by 2, right? So this is my axis of symmetry. Now all I have to do is, if I substitute this into this formula, I would get the answer, right? So I can substitute either in this or in this, right? So if I substitute this to this, I'll get the y coordinate, right? So P of 1 plus d by 2 should actually be equals to what? Q of d plus 17 by 2. Agree? Because in the statement they are telling, right? The y
Yes, sir.
coordinate of the vertex of P of x is equal to the y coordinate of the vertex of Q of x. And these are my y coordinates, right? Now all I have to do is substitute there, right? Right? So if I do this, what do I get? So what do I get? 1 plus d by 2 minus
To
1
the whole square.
and 1 plus d by 2 minus d
Minus d
is
equal
equal
to
to, go ahead,
d plus
d
17 by 2 minus d
minus d, then
into d plus 17 by 2 minus 17.
minus 70, right? So is there anyone who has lost hopes that they cannot do it? Is there anyone? I have solution for you. Tell me, is there anyone who has lost hope, that he just revised everything, but still I cannot do this problem?
I didn't understand by that P of 1 by plus. Here, the last steps, how you
The
expand
last
it.
step. Okay,
Yeah.
you tell me, if I have axis of symmetry, let's say I got my axis of symmetry x is equals to 2, how do I get the y coordinate for that vertex? If this is my 2, how do I get the y coordinate?
By putting
This
x
part.
equals to 2.
Where? In the main function,
Yes, sir.
right? In the
Mm.
function. Okay, so now this is my axis of symmetry.
Yes.
And what is my main function? This one.
Mm-hmm.
And
Yes,
what
yes,
am
yes.
I doing? I'm
Yeah.
simply substituting there,
Yes,
right?
sir.
But I'm
Understood.
substituting to this one, okay? This part.
Yeah. Okay.
Understood?
Yes, sir. Thank you.
Yeah. So my question I asked you earlier, how many of you have lost hope that you cannot do these kind of problem? Is there anyone? Okay, assumes like all of you are fine with it. So well, we can go ahead. But you see, it's actually not difficult. All we have to do is just, it's a tweak of this and we are just doing more calculations here, right? And this question will actually tell you, okay, just revision is not enough. You require practice, right? You just cannot go with an assumption, okay, I know everything about the quadratic equation, I can do problems now. It's not that. Problem solving is a skill, right? And how do you develop this? When you do more problems. Okay, so that is something, even though you know the formula, you know everything, but still you cannot solve a problem. That is something when you do more problems, you understand it. Okay. So, and that is also not very difficult thing. You can actually do that. Okay. So you can just solve 5, 6 questions. You yourself will build the confidence and you'll be like, okay, now I'm in condition that given any questions, I am able to answer this. When you start getting that feeling, right, then you will be able to answer some of the things because that confidence is needed. Okay. Now let's simply expand and get the value of d because this is what we want. And once we get the value of d, and we can simply substitute here to get the, we can substitute in any of this p of x or q of x to get the answer, right? So okay, let's get the answer. So how do you get this? So now if I expand this further, so I can write this 1 plus d minus 2 by 2. And I notice this 2 is common everywhere, so I'll just ignore that 2. Okay. So I'll just keep this 1 plus d minus 2d and d plus 17 minus 2d. Then I get d plus 17 minus 34.
4.
Right? And this 2 was common to everything, so I just cancelled them out. Okay. So now it's just that I have to expand this further. What do I get? D minus 2, d minus 1 from here. And from here, what do I get?
Minus d plus 1.
Minus
1.
d plus 1. Okay.
Yeah.
From here, what do I get?
17 minus d.
17 minus d.
So what do I get? 17 minus d. And from here, what do I get?
D minus
d
17.
minus
D
17.
minus 17. Okay, so something is happening here, right? So what is that? So you see this, I can take out this minus out common from here. So if I do this d minus 1 and I take it out minus, so I
The
can
whole
just simply write this as minus 1 and then I can write this as d minus 1, right? And
d
d
minus
minus 1 times it is d minus 1 the whole square, right? Okay, and then what more I can do with this? Okay, instead of
Minus of
doing
d
this
minus 17 whole
factorization
square.
and coming to this, okay, and I can do the same thing here, that is d minus 17 the whole square, right? Now, and this minus will get cancelled, right? Now, all I have to do is now think of this expanding part. And why did we write this in this way? Because it's easier for us to calculate this further, right? So now I have to find out for what value of d these are equal, right? So how do I get this? Simply expand this. D square minus 2d plus 1, correct? D square, from here what do I get?
Minus 34d
Uh-huh.
plus
Plus
17
17 square letters. Keep it as it is. Okay, so how did we get this? Again, we have this formula a minus b the whole square, which is nothing but a square minus 2ab,
plus b
a
square.
square minus 2ab plus b square.
B
This is the
square.
formula, and that is how I was able to expand this. Okay, so now this d square gets cancelled, right? And I have minus 2d and I have minus 34d, right? So when I simplify this, if I bring this 34 to the other end, what do I get? I get 32d,
32d.
and this is 17 the whole square minus 1. What is 17 the whole square? Can anybody tell me?
289.
289
Yes, sir.
minus 1, and this is 32d. 289 minus 1 is how much?
288.
288. And if I have to get this d value, what do I do? Divide this by 32. So what do I get?
9.
288 by 32 is how much?
9.
9. 9. So there is someone who told 9 in the very beginning, and now he'll be like, why should I do all these if I already know that the answer is D, right? D is 9, right? So it's just because this was symmetric, you are able to tell this as D. If it is not symmetric, you cannot say as 9. It will be varying, but this is the right approach. Okay. So you see, I'm explaining this. That is why it is taking more time. So do not worry about this. Okay. When you are doing at your end, when you have enough practice, this can be done at very fast pace. Okay. So what did we get till now? We got this D value, and what was the question which they asked us? Find the value of D. And we got the D value as 9, and we got this answer, right? And this was 2 marks problem in your end term exam because this is easy problem. Okay, so all of you clear with this? How do you approach these kind of questions? And now you are able to understand that just knowing the concept is not enough. Practicing is very important, right? All of you clear with this?
Sir.
Hmm.
Sir, but this method is very long.
Okay, any other method that you can suggest?
Sir, 1 plus 17 upon 2,
What is the reason? Tell me what is the reason that you're using that formula?
because it is a midpoint or leading coefficient is 1 or on the px and qx. So we
Okay.
can take a midpoint of them.
Okay.
Their slopes are same too.
Okay. Their slopes are same to where? Here at this place. The
No,
slopes
sorry,
are not same. Slopes are
the same.
magnitude will be same, but the direction is different. That
And
you
the
can say yes.
minimum value is same.
2ax plus b, that is something you are using the slope, and but again, what is your a and what is your b? A is agreed that you got this a value as, so 2x plus b will actually be equals to 2x plus b, which will be on the negative side like this, right? But we don't know what is the b value, but that is something we can find out. But what, again, you will have two equations here.
Yep.
You must know what is the slope. Again, you cannot apply this here, because
What
even
about
though you know this, the slope is going to be this, because when you substitute this x value, x is nothing but your d. So you have two variables, right, to find, but you just have one equation.
the minimum values? They are same.
Minimum values are same, that is already given, yes. Then how do you go? You mean to say the slope at this place is same, right? And that is equal to 0. But what is this value? That value is important, right?
Yeah.
You can think of all possible ways. You see, the best way I would tell is, if you do with the smartness, that
Sir,
yes, what you can actually
if the
apply
lead,
this axis of symmetry thing.
yeah, excuse
What
me,
some
sir.
person told it. Yeah.
Yeah, when the leading coefficient is same, then will that also, I think,
How will that help you out? Minus b by 2 is your axis of symmetry, right? And
okay.
over here, the axis of symmetry is not going to be minus b by 2. It's going to be something else, and that is one way that you can think of. But you see, the
What's
best way
best
would be
factor?
what?
Yeah.
The best way for doing this is, you understand that the leading coefficients are same, and of course, by hit and trial thing, you can say that this is going to be 9. It's just that this is one step ahead of this, and then you divide by this, like 17 plus 1 by 2 is giving you 9. Well, that I agree, that is right. Why? Because it's only because these two are symmetric. That is why this answer is getting right. But if it is not symmetric, that won't be right. And this is one way I came up with. If you have any other way, that's much appreciated. You can think of it like how you can get 9. Okay, let's go to the next topic, because if we discuss more here, we'll miss out the other one. All right, so now
So when
in
leading
week 4,
coefficient is not equal, when what to do?
then the problem statement will be changed accordingly.
Okay, sir.
Yeah.
Sir, where can we find such problems for practice, sir?
You see, there are
Yes.
these mock questions are given, right?
Yes, sir, but such problems, it's not there,
See,
sir.
you cannot actually cover all these kind of questions. See, because we always create new questions, right? So how will you get it? Because in your quiz, we try to give some different question altogether. You will not get it
Yes.
anywhere, and this is something we are breaking our head, and we are, making those questions. You will hardly get it anywhere. These
Okay, sir.
questions
Okay.
are very unique. You will not get it anywhere.
Okay, sir. Now, whenever I face such questions now, sir, it looks like I know all the words and all the concepts, but how to crack becomes a challenge.
So that skill is something we have to develop. Given a new question, how should I be able to approach it? That skill, that learning skill is very important. Because you cannot do, some 1 lakh problems and come to exam. That is not right, in fact. And what
Yes.
are you doing is you're actually mugging it up, I would say. You're actually just, mugging it up. Okay, if these are the variations, this is how it is done. That's not the right thing. What you have to develop is, given a new question, how do I solve it? That skill thing is something you have to learn. Okay.
Sir, actually,
Mhm.
studying after quite a break itself is a big challenge for us. So apart from that, finding such things, no, it's adding on to us. But still, we'll have your words and we'll practice more, sir. Thank you.
Yes, yes, yes. Please do that. Yes. Okay. So
So,
how many of you know? Yes.
so it is quite difficult when we have means dealing with the real world questions means related to the real world.
Mhm.
So
How do
means
you
it
tackle
is
those kind of things?
in terms of quadratic equation when we have means tackle to means with a real world question how to convert it to the equation that was quite means difficult to solve. So how to means solve that?
I would say only practice is the solution here. Otherwise, it's going to be difficult.
Mm-hmm.
It's just you have to practice. You just read the question, try to frame equation by yourself, then see the solution. Okay, this is how it's done. Build up your base saying that, okay, this is, if these are the question, this is how it is done. Then given a similar question, are you able to do the same thing or not? If yes, then yeah, you are going in the right track. So that's how you have to do the learning. Okay. So I would say that do practice more. Now let's quickly get into this week 4, okay? Else we'll miss the thing. We have just half an hour now left. Half an hour or something, like more than that a bit. Okay, so now how many of you know how to draw the graph of a polynomial? Can all of you draw the graph of a polynomial? Any of you?
Yes, sir.
Yes, sir.
Yes, sir.
we will look
No,
at
sir.
the
Yes, sir.
keys and the
Not very
signs.
confident.
Not really confident? Okay, fine. So if not really confident, I would say that, watch some of our sessions before and get confident in that, because that's really, really important. If you don't
Yes.
learn it now, you will struggle it in the later weeks, like week 5, 6 onwards. So learn these concepts. This is very important, and this is something you can see, like so many questions will be asked. Okay, so learn this graphing part. Okay, over here I'll just revise, like, okay, what is the thing, but in depth, this is something I have done before. In any of week 4 live session, you can go check. You can see my live session also. I have discussed this, or you can see the revision session of previous qualifier that we have done. It's all extensively discussed. Okay, so over here we'll see that.
Sir, where do I find the revision session for the previous qualifier? I'll have to find it from YouTube or it's there in the dashboard?
It's there in the dashboard. You can see in your calendar also.
Okay.
Or you can go to the dashboard. You can see YouTube links, play.
Okay.
You can get it there
YouTube
also.
links
You
are
can get
there. Okay. Yeah. Thank you,
Yeah,
sir.
you can get it from that. Yeah. All right. So now let's quickly get into this thing. Now, degree of polynomial. Now we know that the degree can be either even or odd, right? These are the only two possibilities that we can have, right? For an example, the degree is, if the degree is 1, then is this even or odd?
Odd, and the
Odd.
graph is gonna be a straight line.
Uh-huh. What about this? 2. Is it even or odd?
Even.
Degree is
Even.
even or odd?
Even.
So this is what I meant. Is this even or odd?
Even.
Even.
Even. Okay. So this is something we have to understand. And we also have understand what is the leading coefficient. Now, leading coefficient can be either positive or negative, right? These are the only two things that we can have. There are certain roots, well, fine. Then what is this multiplicities? Multiplicities is nothing but how many times that root has been repeated. For an example, here 2 has been repeated how many times? 10 times. When we were writing x minus 2 the whole square, if I have to draw the graph for this, how we used to get something like this, right? And it is whole square, that means 2 has been repeated how many times? 2 times,
Okay.
right?
Yes.
This is what it means. So this multiplicity tells us that how many times this root has been repeated, right? So over here, when it is power 10, so 2 has been repeated 10 times. This is what it means. Okay, now, and we have to know.
Sir, I can't hear you.
Can't hear you, sir.
You can't hear me? Am I not audible?
You are audible now.
Yeah, now you are.
Audible? Okay. All right. So now you see this. And what are the other prerequisites? So prerequisites is nothing but you must know what is this multiplicities, what is this root, and what is this leading coefficient, and what do we really mean by this degree of a polynomial, right? There are certain prerequisites that these terms you should know. And graph of certain things, that is x square, the graph is like this, opening upward. Why? Because this is 1. Positive value, the parabola opens upward. What is the y-intercept value? 0. right? Axis of symmetry is y-axis, right? And that is why you see this graph coming like this, right? Similarly, if it is minus x square, so the graph is going to be like this, just inverted downward. So parabola opening downward. So what you have to really notice from here is when this is x square, when it is x square, so square means it is what? Even or odd? Even. So this parabola opens upward, right? Parabola opens upward and the endings are on the same side. This is very, very important that the endings are on the same side, right? So no matter if I have to take x to the power of 100, if I have to draw the graph for this, you would notice that the graph is something going to be like this. It's getting more steeper and steeper and then it goes like this. So you see this, still the endings are on the same side. This is what we have to notice. Okay. So I hope you are getting something out of it. So when the parabola, so not parabola, when the polynomial is an even degree polynomial, you notice that the endings are on the same side. Okay. And it is somewhat coming down to a root and it is bouncing back. This kind of nature you see, right? It's bouncing back means it's basically going to the same side, and that's what you notice from here. And what happens with the cube? Now look at this, the graph of cube is something like this. Okay, and when you're giving minus x cube, it's going to be something like this.
Do
Right?
we start graphing the graph from the left side or the right side of the y-axis?
What do you mean by that?
Like from the, like there are 4 halves in a graph, so from the right up a half or from the left half?
Okay, that you will understand as we are going ahead. That you will be able to understand, so no worries. So you see this x cube, the graph of x cube. So this is prerequisite. That is something we should know, that x square graph is like this and x cube minus x cube graph is like this. Or the graph of even degree polynomial is something like this, where the endings are on the same side, and the negative, with the negative coefficient, it's going to be same. Again, the endings are on the same side. It's just that it's been inverted. But when it is an odd degree polynomial, you will see the graph something like this. Okay, and you see that the endings are on the opposite side, right? The endings are on the opposite side. Likewise, if I have to take minus x cube, you see that the endings are on the different side. Why? Because of this is odd, that's why. And this minus thing has just inverted this, that's it. So these are some prerequisites that we have to know. Now what happens is, if I have graph something like x, if I have to tell you like x to the power of 4 plus, no, not like that, but maybe if I have to tell you like x minus 1, x minus 2, how will the graph look like? So what do you really understand by this is, okay, when you multiply this, what degree you get? What is the highest degree of the polynomial you get?
X square.
2, right? So you get 2. That means, is it even or odd?
Even.
Even. What is the leading coefficient?
Positive.
1.
Positive. So all we have to know is, if it is even and the leading coefficient is positive, the graph is something going to look like this.
X square.
Parabola opening upward, right? You can always think of that way.
Yes,
And
sir.
something is happening in between. It's because of these roots, right? But the end term behavior is something like this. The parabola opening upward and the endings are on the same side. So when I say parabola opening upward, itself is like the endings are on the same side. So now what is the next thing that we do is we find out, okay, what are these roots? So what is the root from here? 1, and this is 2, right? Okay, so this is 1 and this is 2, okay, and then what is the multiplicity for this? Multiplicity for this is 1 and 1. So if the multiplicity is 1, it's going to cross this in a linear fashion. And again over here the multiplicity is 2, so this will, because polynomial, the graph of a polynomial is smooth, right? So this will go in a smooth fashion, and again this will cross it this way in a linear fashion. Look at this. What is this? This is x cube, right? So over here what is happening, as this is x to the power of cube, that is why you see a slight bending here at the root, right? Had it been x to the power of 5, this would have been still more steeper like this and it would have come, right? And had it been just x here, how it is going to happen? Just cross it in a linear fashion, right? So you understand now, right? Okay, so now these are certain things that we have to understand before going to the main questions of this type. So if I have to take you to the main question, so I'm not discussing more on this, but again as we are discussing some questions, so we can understand this, like how we are doing. Like even if you understand one question, you can do many problems of this type. Okay, so now look at this polynomial. Okay, so what is step number 1? This solution step. Whenever a polynomial is given, just draw the graph of this. What is step number 1? What is the degree of this polynomial? What is degree of p of x? Quickly tell me.
10.
Thus,
10?
9, sir.
All of you see and tell me.
9.
2, 3, 4,
What is the
5,
multiplicity of
4,
this?
5,
1. Okay,
6,
so 1 plus
7,
2 makes it 3. 3 plus 2, 5. 5 plus 1, 6. 6 plus 1, 7. 8, 9, 10. So
10,
totally 10.
10. Yeah.
Right? So what is the degree of this polynomial? 10. What is the leading coefficient? From here I get 1, 1, 1, 1, 1, 1, 1. So all these are positive. And what is the nature? If all of these are positive, that thing is getting multiplied with this negative term. So the leading coefficient is going to be positive or negative?
Negative.
negative.
Negative. So now look at this. This is even and this is negative even. So can you think of this parabola? The parabola will be like
Downwards.
this or like this. This
Downwards.
one, right?
Downwards. Yeah.
Yes.
Downwards. And something is happening because of these values, because of these multiplicities. Okay? It is not like you have the graph like x to the power of 10 minus x to the power of 10. If this was the case, how would have been this? This graph would have been like this, right? But as this is not like this, you have some factors in between. So there is some event is happening in between, right? This is what it's happening. That's something we have to understand. So now let's see this. If this is the case,
Sir, when is negative, so we draw towards downward.
that is what you do, right? When it is x square, how is the parabola? Opening upward or downward?
Downward.
And when it is negative, then what?
Downward.
For both you are saying downward.
Upward.
Sir, negative downward or positive upward.
Parabola for, look at this x square. Is this parabola opening upward or downward?
Upward.
Upward. It's because the leading coefficient is positive. We write like this, right? Ax square plus bx plus c, where if a is greater than 0, then the parabola will open upward, right? We studied this, right? So if you have just this x square, what is a value?
1.
1.
1. So is this greater than 0?
Positive.
Yes.
So parabola will open upward. You understand?
Sir, is the
If
sum of
not,
multi-
watch it again, because
Sir,
we
is
should
the
not
sum of
entertain.
multiplicities, sum of multiplicities equal to degree of the polynomial?
Yes.
Or is it less than?
No.
Or equal
It's actually going to be equal to the degree of the polynomial.
Okay.
Okay.
Yeah.
Okay. So now what are the roots for this particular polynomial? So from here, what root do I get?
1.
1.
1. Okay.
4
So let's
minus 1.
arrange it in an decreasing to increasing order. Okay. So from here 1, 2, 3, 4. From here, what do I get? 0. From here -1, -2. So I'll start with -2, -1, 0.
0.
Then what is the root I get from here? 4,
1.
3, 2, 1. Right? These are the roots I get. Right? So now if I have to draw the parabola now, and we know that it is going to open like this, right? Okay.
Yes, sir.
So if this is the
Yes,
case,
sir.
then what is the least root that we are getting? -2. So I'll
-2.
just identify this as -2. And what is the highest value that I'm getting?
4.
4.
4.
2, 3, 4 is something I should write. 1, 2, 3, 4. Right?
Yes.
So the highest value, something that I'm getting is 4. Right? Now I'll just mark all other roots on this line. So what are the other roots? -1,
-1. 0.
then 0, then 1,
1, 2, 3,
2,
4.
3. Right? So now what? Now I have to look at the multiplicities for each of these roots. What is the multiplicity of -2?
Even.
2.
2. So it is bouncing
That's-
back type, right? So what
That's
happens when it is x square? So this curve will go here and it will
Touch the
bounce back.
x-axis and bounce back.
It will touch the x-axis and bounce back. What is happening over here? What is the multiplicity?
कट करेगा ये. Or
Or
1.
So it will go like this
cross the
and it will go
x-axis.
in a linear fashion. What about this? Multiplicity is 1. So again, it will
1.
come down like this, cross in a linear fashion, and
Cross.
like this. Right? Again, come to this part. So are we done with these things? We are done with all these, right? Now we are
Yes.
coming to this one.
Yes, sir.
So this will cross in a
Exactly.
linear fashion. And over here, look at what is the multiplicity of 2?
It's 2 even. It will
2
bounce back
even.
at
So
the
it will come back
x-axis.
here and it will bounce back.
Touch the
What is the
x-axis.
multiplicity of 3?
2
Even again.
2.
comes back.
It will come here, bounce back. What is the multiplicity of 4?
1.
It will come here, but cross in a linear
Cross.
fashion.
Exactly.
So this is what the graph you get for this polynomial p of x. Okay. And the rest, how big this is and how small this is something we are not interested. Okay. That is something we cannot even determine. Okay. So now we have to look at certain questions here. Now p of x is one function when x belongs to minus infinity to minus 2. Okay. So this is one region that we are talking about. This is one region because this part is this minus infinity to minus 2, and the other part is 4 to infinity. 4 to infinity is this, right? So is this 1 to 1?
No, sir.
It is not. It's just because you just simply draw a line like this. It'll cut at two different places, right? And therefore you can say that this is not 1 to 1. It fails the horizontal line test, right? So this is gone. So the first option is wrong. What about the other thing? Total number of turning points for this p of x are 9. So how many turning points do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So is this right? Yes, this is right. P of x is strictly decreasing when x belongs to 4 to infinity. 4 to infinity. So what happens? 4 to infinity, as x increases, what is happening to this functional value? It is increasing or decreasing?
Decreasing.
So is
Decreasing.
this right?
Yeah.
Yes.
It is decreasing. There are exactly 9 points on p of x where the slope of the tangent can be 0. So wherever this turning points are, those are the places where you see the slope being 0. So how many places are there? 9 places are there, right? So even this is right.
Sir, can
Okay,
you
clear?
explain the first one again, the one function one?
Okay, so before explaining you one, look at this function, okay? Okay. Now, what do you mean by one function? It's basically if you have 1, 2, and if 1 means basically this is mapped uniquely to the other one, right? So you
Yeah.
see this, you cannot have something like this. If you have 1, 2, you cannot have something like this, right? A two different domain value giving you same output, right?
Okay.
You cannot have this thing. So
Yep.
if I have to simply draw this line over here, just simply I'm drawing one horizontal line here. Now if I have to project this down, okay, let's call this as y-axis and this is being 0. Fine. So and call this as 2 and call this as minus 2 and call this as 2. What you notice from here is when I simply draw a horizontal line over here, right?
Yes.
If it cuts at two places, then it is not a 1 function. If it cuts at two places, it is not a 1 function. Why am I saying you this? Because look at this. At minus 2 and 2, let's say this value is 3. So is this happening here? At minus 2 and 2, I'm getting the same output,
Yes.
right? And therefore this is not 1. You
Okay.
understand?
Yeah, we are getting the same y value.
Correct.
Y.
So over here also what happens is they are saying, no, if you take this value and if you take this thing, what happens when you draw the horizontal? And if I simply extend this, there is definitely two places where it's going to cut, and if I have to project this down, I would see that the value is going to be same, right? And therefore I can say that this is not 1. Agree?
Yeah.
Okay. So that is all about this. Now let me quickly discuss with you. So if you want to do more of these kind of problems, just see the previous live session videos. Okay, that will help you out because I cannot take 2-3 examples of this type and miss out the other topic which I have thought which is really important from your examination point of view. Okay, so let's do this. If you want to do more practice of those kind of things, just see the previous live session videos. That will help you out. Okay, because it will be the same thing I'm iterating it here, which is not right. Now you see this, as I told you, there is one question called SSC type question, which is involving your polynomial concept, right? So this question is something given in your mock as well. So over here, you see the question is something like this. Rizwan wants to cross the river represented by, so this blue color is the river which is represented by this expression. Okay, where k is an integer constant, where this k is basically an integer value and it is a constant value. Okay, now he chooses to cross the river. This river is represented by r of x. Okay, using the bridge. This thing is bridge. What you see is a bridge. Okay, bridge. In order to cross the river, he has to identify the coordinates of the point A. So basically, Rizwan wants to find out what is the coordinates of A if he wants to cross this river. He realized that the coordinates of the point A can be identified in such a way that the curve r of x can be best fitted. Now look at this keyword. Best fitted according to the data given in the table, and the table is given. This itself is a clear indication that you have to do SSE. Okay. Now consider the river and a bridge to be a negligible thickness. Based on this information, answer the following question. What is the value of k that we have to find out? Okay, so from this polynomial which is given, this polynomial, what is the value of k? That is something we have to find out. Okay, so now we know this SSE formula. All of us know that SSA is nothing but sum of y minus y cap the whole square, where y is nothing but given value, and let's say this is predicted value. From where are you predicting this? You are predicting from this, and given value is something here. This is my y values, these are my given values, and if I substitute this x in this polynomial equation, I get some predicted value, right? So if I take the difference of both and square it, that is for one coordinate, for basically for one pair, I get one value, right? So if I add for all of this, I get the SSE, right? So that is something we have to understand, like what is SSE? So SSE is simply summation I equals 1 to n. Over here, what is n? 1, 2, 3, 4, 5. So n is what? Summation 1 to 5 yi minus y cap the whole square. And what is your y cap? Y cap is nothing but your this one. And how do you get the y value? You just have to simply substitute the x in this and get the value, right? Clear? So once we do this, we get some value, right? After substituting, we get some value. And what is that value? We get some value, let's say. And that value will tell us, okay, is there something that I can do more with this? So you see this, for simplicity, I have already founded out this SSE thing. So this, look at this f of x value was what? I'll just do for one, okay? And I'll explain you that part. Just give me a minute.
Sir,
Yes,
sir, is this meeting being recorded? We'll get this on the YouTube.
I doubt that you will get it. I
Okay.
doubt. I don't know. Yeah. Okay. So now I think I have this here. Fine. So let's discuss this here now. So you see this is my tabular thing which is given, and you know my r of x was what? So instead of instead of f of x, I have mentioned here. So this is not f of x, rather this is r of x, right? So what is my r of x? R of x is nothing but 0.05 x minus 1, x minus 5, x minus 10 plus k. So let me find out for x value when x is what? When x is minus 10. This is something I have written here, right? So I've just taken this minus 10. So when, what do I get this r of minus 10? What do I get from this? So if I simply substitute this, this is something done here. You can see this y cap, I told you, right? How did we get given value? What is a given value? Given value is nothing but for this corresponding x, what is the given value? Minus 150, that is something substituted here. Then minus, what is y cap value? Now y cap value is something I am trying to show you here, which is actually done over here also to show you that how is that done here, right? So just for simplicity, I'll tell you that 0.05, what is x value? Minus 10. So minus 10 minus 1 will make it what?
Minus 11.
Minus 11. So, or you can simply write it down here. And what is this? Minus 10 minus 5, minus 10 minus 10 plus k, right? And this has this, I have to subtract from the y value. So this is something shown here. So minus 150 minus of this value, which is something I have shown you here, right? And then I have to square this entire term. This is what it tells, no? That you have to square this entire term, right? So yi minus y cap, the whole square, right? So I just have to square them. So I get something like this, right? So I square them, and when I square, I get this value. Likewise, when I do for the other points, I get some value like this, like this, like this, like this. And I notice that all of them are same, right? All of them are same. So what do? I add them all, because SSC tells you what? You have to add everything, right? You have to add each and every term, right? So I'm adding them. So this is what I get SSC, right? So now notice one more thing. This SSC is a quadratic equation. I mean, it's a quadratic function, right? And it is quadratic in which variable?
1.
1. What is the variable here? K, right? So essentially what it is something like 15. So it is something like 5 into 15 minus x the whole square. It is something like this. So instead of x, this k is given. Okay. So now you notice this. I have to find out what is SSC. In SSC, if I want to do best fitting, I have to minimize SSC, right? Right? I have to minimize SSC. That means SSC must be minimum. It has to be minimum, right? Look at this quadratic function. This is a parabola opening upward or downward?
Upward.
Upward. So you will have a minimum value for some value of k, right? You will have a minimum value for some value of k, right? And how do I get that?
0.
Finding the vertex.
Not finding the vertex, but axis of symmetry. Because at axis of symmetry, you get the minimum value, right? So when I simply do this, what do I get? So this is going to be k square minus 30k plus 225. Or simply just write down 15 square. No, not even break your head in expanding this. Okay. So now what? If I further expand this anyways 5 is common. So, but to all of us, I'll just simply write it down. 5k square. You don't really have to deal with this, but again, minus b by 2a, right? So what is minus b? Minus 30 minus of minus will make it what? Minus 30 plus 30 divided by 2. A is nothing but 1. And look at this 5. 5 is common to this a, so I can write this 5 here and I can write this 5 here. So this 5 gets cancelled, and then I'll be left with what? 15. So what is that b value that I'm getting? K value that I'm getting? So at k equals to 15, I get the minimum value, because this is what my coordinates, no, for vertex. And when the parabola opens upward, I get the minimum value, right? Definitely I get the minimum value. So the question is, for what value of k we are getting the minimum value? For 15, I'm getting the minimum value, right? Agree, all of you with me?
Yes.
Yes. So with that, we get that k value is, what is find the value of k? So k value is 50. So just to tell you again, how did we do? We first find out, okay, what is the SSC? After finding out SSC, we found a very nice equation, something like this, which is of quadratic type, right? Which is of what? Quadratic type. Now this quadratic expression, now if you see this quadratic expression, there is something interesting to see, that this is a parabola and this parabola is opening upward, and I have to minimize SSC. SSC is actually giving me the value of this, basically and where do I get minimum SSC? At the vertex, right? The y coordinate of that thing will give me the minimum value. But for what value of k? Because we are interested in finding out k, right? And k is the variable, right? So when I do that, so I get that k is nothing but my axis of symmetry minus b by 2a, and that is nothing but 15, and that is something I got it here, right?
So
And
if we calculated the first value of SSC, all the other values will also be the same.
it need not be, but over here I found it out. I did not show all the things here. I did not show you all the things.
You just wrote down the answers, right?
I did calculation elsewhere and I have written it here. It is not going to be same. Okay, it may or may not be same, but in most cases it is going to be same when it is polynomial or something like this. In most cases it will be same. Okay, but do not take it for granted that it is going to be same.
Okay.
Okay, clear?
So if we are asked to find the minimum value, like not k but the minimum value, so we'll substitute the value of k and find.
If you substitute the value of k and you get the value, then what do you get? You get the SSC value, in fact, and that SSC is your value, right? Isn't it?
Okay, got it. Yeah.
Got it? Yeah.
Yeah.
Okay, so the next question was over
Sir,
here.
May I ask
Sir,
a
wait.
question?
Yes, please go ahead.
Yeah.
SSC is the
So-
minimum value, right?
Go
One
ahead.
person.
SSC is the minimum value, right?
SSC is the minimum value, yes.
In general, 0 is possible, sir?
No, it is not possible. Because you look at this, you can actually substitute and see, yeah, actually it is going to be possible. Because when you substitute this 15 to this, what do you get? 5 into 15 minus 15 the whole square, which is 0. In fact, this curve is something going to look like this. If this is 15, right? So this is 15. So this is something going to be like this. This is your 15. This parabola is going to be something like this. And this is your SSC. Right?
Okay, okay, sir.
Clear? All of you clear?
Sir, when
Yes.
the data is not given, so what to do?
You have to identify the data. Which are those data? But most likely data will be always be given.
Sir, in qualifier
Then-
exam, there is no data given,
For
only
finding
FX
SSC?
values given. Yes,
Ah,
sir.
so you see in that thing, this was only this part was given to you. Only this part was given. Right?
Yes. No, sir.
Right?
Yes, sir. Yes.
Yes. SSC, which was represented in a quadratic function. I was the one who made that question, so I know what it is. So it was just this step. So it was just this step, and we were asking you that, okay, what is the value?
No,
Right?
sir. It is fx is equal to a square plus 14a plus 15. Exactly. I don't remember it. But this type of fx is given. Only find the SSC minimum. SSC find given. Or answer
Right.
is 14. But why?
So that is the value that you had to find out, na?
But it is the maximum value when we put in the equation.
No, it's not going to be like that. If you want, I can show you that question, and there is no error in that. So you see, what is given there is basically a question is given, which is in the form of quadratic, like this. Okay, and the only thing that you have to, we asked you, okay, what is the SSC value? SSC value will not be K, but the value itself. Over here, you are finding out K because you were asked to find out K. Right?
Yeah.
You notice this? What is the value of K? This is not SSC. SSC is when you substitute this K value into this, then you get the value. Right? The SSC value you get. But we are not asking what is SSC, right? We are asking what is the K value. Isn't it?
Why is the K minus B by 2A?
Okay, it's just because you see, look at this parabola. See, do not forget your quadratic also here. Quadratic is, this is a quadratic.
Yeah,
Is this going to open upward or downward?
upward.
Upward. Okay, if it is going to open upward, then will it have minimum value at some place?
Yeah, it will be minus B by 2A.
So at that place you will get that K value, and when you substitute that K value, you get the minimum SSC. Clear?
Okay.
Fine. Okay, so the next part of the question says, using the above information, what will be the y coordinate of point A? Now look at this part. Now this is a bit interesting. So what happens is, once we have found it out, after so much of calculation, we relax, you know, we're like, okay, we have done so much. But the question does not end there. You should understand this. This is like normal tendency. Even if I am you, what I'll do is, okay, I have done so much, you know, calculation. You know, I got the answer finally, like, you know, SSC is this, K is this. Great. Now, what is this Y value they are asking? You know, we tend to relax, we go into a comfortable way, and then we do not actually realize what is the next part of the question that they are asking. Right? So this is like a very, you know, a normal tendency, but come over it. Okay, that is very important. So what is the next thing that they are asking over is, okay, using the above information, what will be the y coordinate of the point A? Now look at this, point A is here. Now if you have to think of this way, just think it as what? Points is given, 0, 10 is given to us. Now 0 means what? X-axis is 0, right? And what is the 10? This 10, notice this is 10, right?
Y coordinate.
So if I have to expand this and I have to bring it, so definitely this is my 0, 0. This is how it's going to be. Right? All of you clear? Because you see, this is my x coordinate. So definitely this at the bottom, I'm going to have my origin, right? Right? And if this represents my polynomial, if this is my polynomial, and if it cuts the x-axis, if it cuts here, that means all I have to do is I have to find out what is the y-intercept of this polynomial, right? So when do you get that? When do you get that?
We put x is equal to 0 in the
Exactly, just put x equals to 0 into this. What do you get? When you put r of 0, you get the y coordinate for this, right?
Okay.
So what do you get? So this is going to be 0.05 minus 1. Why minus 1? Because this is 0. And this is also 0, so this is going to be minus 5. And this is going to be minus 10. And what is the k value that we are getting? What is k value?
15.
15. And all we have to do is just simplify this. What do you get from here when you simplify this? Okay, first let me deal with this minus thing. So minus, minus, minus. So there are 3 minuses. So this will become minus overall. And this is 0.05 into 10 will make it what? 0.5 into 5 will make it 2.5. Right? Plus 15. So this is going to make it what?
12 point.
This is going to make it 12.5 overall. So this
So
point A
make it
will have the y
0.25.
coordinate as what? 0, 12.5. And they are asking y coordinate of the point A, which is nothing but 12.5, and this is the answer. So you're getting something now? How to get the answers?
yes.
So
What
there are calculations, you see? There are calculations, right? And how do you do this? You will be given very less time, right? 1 hour or something, and you have to do it in that time, right? So where is that you have to do? Put your effort in practice, right? So do as much as practice you can, because that is the only thing which will save you in life.
So,
Okay.
Sir,
One
the
more
question
thing
is
is
given.
quickly about that qualifier FFE question. Is it possible?
okay. But before going there, can I just finish the thing,
Yeah, okay,
you know, so that all of us who are waiting for this session to get over, I can just give you a final thing that what you have to do, and then, you know, there was one more thing which I wanted to discuss uh, in polynomial concept itself. When do you say that if you want to find out the intersection point of two equations, let's say if I have basically you have two functions, let's say my function is q of x and another function is let's say this is q of x and this is my f of x. If I tell you find all the intersection point, how do you get this?
equate
F
them.
of x equal to Q of x.
So this is something you should understand. By equating this to this, you get that thing. Okay. But one more thing is you equate this q of x with f of x, but you will find some of the roots. Let's say if q of x is nothing but x minus 1 and x minus 2, and let's say this is nothing but x minus 1 the whole square and x minus 2. Okay, if it is something like this, then how do you solve this? So you write down this in this way, x minus 1 times x minus 2. This is going to be x minus 1 the whole square and x minus 2, something like this. Our normal tendency is cut this, cut this, cut this, and cut this, and I'll be left with x is equals to 1. Right? This is our normal tendency.
Yes.
And you will come up with answer saying, oh, answer is 1, but answer is not 1. It's not just 1, because if I'm asking you find out all the point of intersection, then how do you get this? All you have to do is just bring this to the other end. X minus 1, x minus 2, x minus, this is minus, right? So if I'm bringing this entire terms to the other left hand side, what do I get? Minus of x minus 1 the whole square and x minus 2, not the whole square, but just this is equal to 0. Now I take out the common from here. What do I get? X minus 1, x minus 2. And if I take this common, so what do I get? 1 minus x minus 2, right? And then is equal to 0. And then what do I get? I get x minus 1, x minus 2. And from here, what do I get?
It's
Go
1
ahead.
minus x minus 1.
1
Minus
x plus 2.
Minus x
minus 1.
plus 1, right, is equal to 0. Now you equate to 0 and you get the answer. So now what? X is equals to 1, 2, and from here what do you get? Again 1. So this is the answer you get, right? So you understand this, right? So you do not have to cancel the roots, but rather you have to find out all the roots, right? If you cancel them, you are losing out roots. You understood?
Okay.
So
So
what
this
do
kind
you
of things
divide?
you have to.
Like when taking it to the left hand side, Why won't we divide? Because it's multiply, right?
Because you see, you are finding roots, you're not, you dividing and all. See, the intention for this thing is you have to find out all the values of x where it becomes 0, right? You have to find
Yes.
all the values of x where it becomes 0. So why do you want to divide and all? And why do you want to cancel out roots and all? That does not make sense, right? Because we have to find out
Yeah.
overall how many roots are there. You got it, right?
Yes.
Okay, so that is one thing that you have to understand, and you might have a questions like this. Okay, so you see before, okay, I'll just show you that question, the qualifier question, and then we can, then I'll give you one final thing that I have to say about the exams and what are certain area where you have to focus for your qualifier exam. Okay, those I'll tell, and then we can wind the session. That is really important, that where you have to really focus on. This is week 3 and 4. I told you already. But on week 1 and 2, where you have to really focus on, that's something I'll share you in a while. Just give me a minute and let me see that qualifier paper if I can get somewhere.
I have a question, equation of that qualifier exam.
Yeah, I'll take that question and I'll show you that.
Okay, sir.
I have one doubt in that lecture 4.13, sir said check for symmetry in point. I didn't understood it. Can I recite that line?
Check for symmetry.
Yeah.
What was the concept sir discussing there?
If the function is an even function, its graph is symmetrical about the y-axis, that is f of minus x is equal to f of x.
That is right only, no?
So I didn't understood what he meant to say by that.
Okay, fine. We'll look into that.
And for that odd one too, f of minus x is equal to minus f of x.
Yes, sir. I have same question. Like how to identify even and odd while is given.
No, I'm asking for something else.
Okay.
Which was that question? Okay, let me see.
Sir, it's question number, like the last question in the response sheet.
Did you guys go with the solution? Huh? All of you, did you go with the solution that we provided?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, tell me what did you not understood from this? This was the question, right? Susmita was calculating SSC and she found that the SSC is a function of A as follows. What will be the best fit value, right? This is the question, right?
No, sir. A square minus 6a plus 30.
And this is our SSC, right?
Yeah.
This function represents SSC. Now, what will be the best fit value?
Okay, sir. Now got it.
Sir, its recording session is uploaded on YouTube.
I don't know about that.
Okay, sir.
Yeah.
The best
So
fit
you see
value
this?
will be the y-intercept.
No. This is not y-intercept. Essentially, you have to find out what is the SSC value. That's it. Or you have to find out what is the minimum value of this f of a. What is the minimum value? So you see, this is a parabola opening upward, right? Parabola opening upward means at the vertex you will have the minimum value, and the y coordinate of your vertex is your minimum value, right?
Yeah.
That's it.
Okay. Okay.
So this is like a sub part of what we discussed there, right? But still we gave so much marks. We were like, at least we'll give you more marks for this kind of question, but there shouldn't be a problem, right? Because you see, we just did, that big problem, right? And that problem was of very little marks. Little marks in the sense it was of some 5-6 marks, yeah, but still. So you see, this is one thing. And somebody talked about this symmetry thing. Let me just completely finish this off. So you see this, if this is a quadratic equation, right? And this is symmetric about y-axis, then what do you really mean by f of minus x is equals to f of x is, you take any value. What is f of minus 5? And what is f of 5? You get the same output, right? You get the same output, isn't it?
Yeah.
Yes.
Right? That is what sir meant there. That's it.
It's for even, and what's for odd?
Or for odd, you can just think it in the other way around. Just think it in the other way around. So if it
One
is
is
like this,
positive, the other will go in opposite direction.
correct. So if this is 5 and if this is 5, this output magnitude will be same, right? But the value is changing, right?
Okay. Thank you, sir.
That's it. Yeah. Okay. So now final thing that I would like to say is, yes.
How to identify if the graph is even or odd function?
How do you identify whether the graph is even or odd?
Yeah.
It's in a
Okay, so if
degree.
it is symmetric about y-axis, then you say this is even function, right? And if it is symmetric about origin, then you can say that it is, you know, it is an odd function. So that is something you can do that. Okay, so let me just finally tell you like what is that you really have to focus on, because this is revision session. You have another session called doubt clearing session where you can come in and ask your doubts, right? We'll take up all your doubts there. We understand that you have doubts, but let's keep this as a revision session and take away the final takeaway that you can take from. Okay, so you see this in week 3 and week 4, what we have done today is more than enough, I would say, to get very good marks. Okay, but all you have to do is like these concepts you have to practice, right? Do as much practice you can. And there is
So
nothing more you can think about.
practice assignment, graded assignment, and mocks are enough, right?
Solve them. Practice assignment, graded assignment, mock, and even some questions which is discussed by prof. Tutorial questions. Practice them. There are so many questions. If you do so much, it's more than enough. Okay. Yeah, and do not go with an assumption that you know what is asked in your previous qualifier will be
Yeah,
asked here. No, that is not going to happen. Okay. So if you are to ask me where you really have to focus on, let's say from week 1, 2, 3, 4, if I'm going. So if week 1, if you are to ask me, I would say like set operations are very important. The Venn diagram problem. Okay. So Venn diagram problem is very, very important. Practice them. And that Venn diagram problem is not going to be easy. It is going to be very difficult. Okay. So practice difficult type questions. Do not take up 2 Venn diagram and feel happy about it. That is not going to take you anywhere. Okay. So take this 3 Venn diagram type problems, okay, and try to solve those questions. Okay, word problems type questions, okay, which involve some kind of percentage and all these. Okay, so try those kind of questions. Okay, so that is one hint. And other thing that if you are to ask me, then you just the set builders and you know like set operations only is very important in your first week, I would say. You can just brush on these concepts like what are these functions, right? Those concepts you can brush on. Coming to week 2, I would say that you know go with the statement problems. It's very important. Okay, those questions are very, very important. So the word problems are very important, and it has got some weightage, good weightage of week 2. So you practice those questions. Okay, so from week 2 it's important in
What
terms of
statement problem?
statement problem is you will be given a statement, you will have to frame an equation and then solve it, and or else like you know you will be given some kind of statements where you have to visualize certain things and get the answer out of it, right? So those things. Right. Okay, so now look at the, okay, I'll come to this part now. Other thing is week 3, all that is very important is the graphing part is very, very important. So week 3 and week 4 will be merged with the in terms of graphs. Okay, and SSC, as you know, in week 4 is very important, right? So these are the final thing that you should take from me, and you know you practice accordingly. And I think your next session is tomorrow in the evening, so you practice as much as you can, right? And come up with more doubts we can entertain in the next session. Okay, so this is all for today's session. Thank you all.
Yeah, thank you, sir.
Yeah.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.
Thank you.
Thank you,
Can you
sir.
please
Thank you, sir.
session PDF with us?